Good evening, students. Today we will discuss an important phenomenon, that is deformation by slip and twinning. So, what is slip? You have already known slip plane. Above the slip plane, one layer of atoms get dislocated, distorted, and the another layer remain undisturbed. So that plane is known as slip plane, along which one layer is slipped or displaced over the other layer. So metals deform plastically by slip, and slipping is facilitated in the presence of dislocation. Slip is defined as the process or mechanism by which a large displacement of one part of the crystal relative to another along a particular crystallographic plane takes place, which I have already told. Slip is a process where one layer displaced relative to another along a particular plane, crystallographic plane. So that plane is known as slip plane, and the phenomenon is known as slip. There may be one or more slip planes and one or more slip directions in each crystal. Slip begins when the shearing stress acting along the slip planes in the direction of slip exceeds a certain value known as critical shear. So slip is a process by which plastic deformation occurs. So what is that process? Displacement of one layer relative to the other along a plane. So that plane is known as slip plane. In a crystallographic plane, this slip occurs. How it occurs? When a shear stress is applied on the crystal or on the material. If the amount of shear stress is more than the critical shear stress of that material along the slip plane in the slip direction, then only slip occurs. So slip plane. Slip planes are planes of high atomic densities. When the material is subjected to shear stress, so along which plane this slip occurs, that plane is known as slip plane. And this plane is nothing but the plane which have high atomic densities compared to all other planes. And slip direction, similarly, this is the line or this is the direction along which highest atomic density is there. So, when shear stress is applied on a material, the material starts slipping along a plane in which atomic density is high and along a direction where the atomic density is highest. So this plane is known as slip plane and the direction is known as slip direction. So slip occurs along the slip direction in the slip plane when the applied shear stress is more than the critical shear stress of that material. The displacement of dislocations takes place in such a manner that the displaced atomic blocks don't revert back to their original shape and location after the external force is withdrawn, resulting in a permanent deformation. So when we will say slip occurs, not in a elastic deformation, only when a plastic deformation occurs along a plane where the displacement or the dislocation takes place could not be restored, could not be reverted back, so that original shape cannot be achieved after withdrawal of applied shear stress. So, slip is a permanent deformation occurred in the slip direction along the slip plane when the applied shear stress is more than the critical shear stress, and slip plane is a plane having high atomic densities, and slip direction is the direction having highest atomic density. So this is the diagram of slip. So in stage 1, all atoms are ordered in the lattice structure. In stage 2, shear stress is applied. In stage 3, this shear stress exceeds critical shear stress, and along this plane the atoms displaced. And in stage 4, it is observed that even though the shear stress is removed, the atoms or the lattice could not be restored, could not come to their original position. The deformation occurred is a permanent or plastic deformation. So this phenomenon is known as slip phenomenon. Next one is twinning. So twinning is another plastic deformation in crystal. It is a special case of slip movement. The region where slip cannot take place, twinning takes place. It is shown in the figure. It has two regions called perfect region, and another one is disturbed region. So perfect region carry atoms which are not disturbed during the process, and disturbed region get distorted. The atoms contained between the two parallel twinning planes lie in the disturbed area known as twin bar or distorted region. So two twinning planes. Slip plane is a one plane, but in case of twinning there are two parallel planes. In between these two planes the disturbance occurs, the distortion occurs, and above one plane and below the other plane the atoms are in original position, not disturbed. The position of these atoms in the disturbed regions changed as a result of twinning. Under this mechanism, the applied stress acts along the twin planes, and under the action of this stress, the direction in which this plane moves is called the direction of twinning. This process makes the region lying between the two twin planes to shear in a homogeneous manner, while the two portions of the crystal lying on either side of the two twin planes remain undistorted. The process of plastic deformation by twinning does not occur as frequently as slip. A metal will deform by twinning normally when it cannot deform by slip. The cubic metals having FCC, BCC or HCP structures deform by twinning only under special condition. Cubic metals deform by twinning only under special condition such as at low temperature or during fast forming process. If the process is very fast, then distortion occurs by twinning. Otherwise, the process is slip. The dislocation, the distortion, the plastic deformation process is normally slip in case of cubic metals. Iron, for example, will twin when shock load or impact load is applied to it, or if the applied stress approaches to its brittle state. So, process the yield point is nearly at the area of brittle state. Then iron deformed by twins either under shock load or in the area near brittle state. Similarly, in HCP crystals, twinning may occur when the applied stress is almost normal to the slip plane. Applied stress is almost normal to the slip plane. Twinning normally occur during mechanical deformation called mechanical twinning, fast deformation when the process is very fast, and during annealing after plastic deformation called annealing twinning. So this is the diagram of twinning. In case of slip, one slip plane was there, but here two twin planes, this side and that side, the two adjacent sides of these two twinning planes, the atoms are not disturbed. So in between this disturbed area, plastic deformation takes place. So what are the effects of this deformation on material properties? The mechanical properties are greatly affected by deformation, by plastic deformation. The deformation process like rolling, forging, extrusion, drawing, strain hardening takes place, as a result of which hardness changes, elasticity changes, cracking takes place, grain growth takes place, and residual stress are produced in cold working. So, this metal forming process is nothing but a plastic deformation process. And due to this plastic deformation during metal forming, such as rolling, forging, extrusion, drawing, strain hardening, so these mechanical properties are greatly affected. Sometimes its hardness increases, ductility decreases, and grain growth takes place and cracking takes place, and certain residual stresses are produced, which leads to failure of the material. So we have discussed two different phenomena or processes by which plastic deformation in metal occurs. One is twinning and the other is slip. Slip occurs usually along the slip plane, that is plane having high atomic density, and along the slip direction. But under special cases, When slip does not occur, the metal deformed by twinning, and twinning occurs in between two planes known as twin planes. And these deformations highly affect mechanical properties of the material.